Hey, welcome back to another rebuild series. Today we're going to put together a 480E. Now, if you're wondering why I'm filming another 480E rebuild when I already have one on the channel, the reason quite simply is because that other transmission was set up for high performance. So I think the engine was making 600 horsepower, it was going to be used in drag racing, and frankly, much in the way of the specialized parts and procedures that you may have seen if you watched that video series that we did to that transmission. Are completely unnecessary for a stock or mild performance 480E rebuild. So this video should serve as a really good sound reference template for what it means to go back together with one of these units, if you're not familiar with them, and you want to better understand what parts and procedures you should follow just for a good, reliable transmission that will last a long time. So there's a few choice upgrades and updates that we're going to make that I do to all my 480Es, and we'll go through those, and so you know what those are. Now, one of the things I almost never do with these transmissions, or frankly most, are shift kits. You really don't need to install them. Everything that you want to accomplish when it comes to shift firmness and feel can be done without the aid of a shift kit. So we're not going to install one in here, but what we are going to install are a couple of Sonex parts. So for the pump, we have the 480E LB1 boost valve kit. This is one of the few areas within this transmission that is kind of weak and can leave you vulnerable to high line pressure. So what happens is, as the boost valve oscillates in its sleeve over time, it wears against that sleeve, and eventually it may get stuck. And if it gets stuck in the wide open position where you're getting maximum boost pressure, then you're going to have excessively high line pressure throughout the transmission. All of a sudden it'll start bang shifting in every gear, and parts will start to break if you drive it like that for too long. So that'll mitigate that risk there. It's one of the main failure points that you need to be concerned about when it comes to part selection for these units. Alright, we're also installing, and if you watched the valve body assembly video, you saw us put in there a Sonex TCC regulator valve, along with 1, 2, and 2, 3 shift valve springs. Again, the TCC regulator valve is another common pattern failure issue item. It tends to get side-loaded during normal course operation and wears out the bores. So the Sonex valve has a scarf cut sealing ring that seals off that bore so that doesn't, that problem doesn't reemerge. I mean, otherwise you may have premature torque converter failure or other drivability symptoms. All right. As far as everything else we're doing upgrade-wise, I always install a Chrysler 727 or A518 direct clutch drum snap ring at the intermediate clutch location. I don't reuse the factory snap ring. They're flimsy. Sometimes they'll pop out, sometimes they'll break. Any 480E or TH400 that you're going back with should receive a beefier snap ring. And if you're going to run a Transgo kit, I believe they come in the kits as well. And I think they just throw a Chrysler snap ring in those kits. Alright, so again, you don't need the kit, you just buy the snap ring separately. They're like a couple bucks. So we're going to have an 88 thousandths and 106 thousandths snap ring on the bench, so that if we need to, we can mix and match to get our clearance where we need it to be. Alright, you always replace your one-way clutch assembly, so your overdrive roller clutch, your intermediate sprag, and your low roller clutch. So that box you see on the far end of the bench, that has the low roller assembly in there. Alright, we're gonna rollerize the rear of the case. I always do that with my TH400s and 480Es, and that is just so that we can remove an area of friction and heat buildup in that back portion of the case there. It's just, I think the bearing itself's 10 bucks. You purchase a couple of shims. It's a TH350 pump thrust bearing. They started installing those in all the 1978 and up TH350s that left the factory. So you install that bearing upside down. You install an additional early 480E pump body bushing, just like the one that's in that pump body sitting right there, and that will allow you to locate the bearing. Alright, we replace all the bushings in this transmission. If I were you and you don't already have a blind hole bushing and bearing puller set, I would just make room for an additional 60 to 75 bucks in your budget for the rebuild and purchase one. It makes removing bushings in this transmission so much easier. It is fast and minimal risk of damaging anything. I mean, sometimes you can remove them with chisels and hammers, but let's face it, if you're not used to doing it, even if you are, there's always a chance you'll make a mistake and gouge the bushing surface or whatever. So remove all the risk there, spend the money. I'll put a link to the set that I have. I purchased it off eBay. and I think it was like 65 bucks shipped. And it'll have a collet for every single one of these bushings in this transmission, and make quick work of getting rid of them, getting them out of the part, so that you can press in your new bushings. All right, as far as lube mods are concerned, you can check out my 4LADE lube mod video. That'll give you all the procedures that you need to follow there if you want to improve lubrication flow throughout the transmission. But in a stock build, you really only need to do two things, and that, both of them address the pump. In the pump body, just drill the drain back out to 1/4 of an inch. You just want to come in at a real shallow angle, and then if you're going to run the stock pressure regulator valve, you want to drill a 55 thousandths hole in that area for full-time line to lube. So that'll give you lube at, full lube to your gear train at part throttle. In other words, just normal driving, which from the factory, there is a little bit of a deficiency there. Nothing major, but, it takes 2 seconds to drill the hole just to improve that, that lubrication flow. You might as well do it. All right, all the other obvious stuff gets replaced, paper and rubber, seals, gaskets, O-rings, sealing rings, lip seals, all that stuff. You don't need too many special tools for this transmission. We'll show you an alternative way to resize your one-piece Teflon sealing rings. And in the kits now, they give you interlock style rings for the stator and the pump, as well as the center support. So if you don't want to mess with the one-piece Teflon rings, you can just use those other sealing rings and they work perfectly fine. All right, as far as friction module, we're going to go with Alto High Energy. I got a good deal on a set. Just to be clear, you do not need to upgrade the frictions from the factory Borg Warners. They work perfectly fine, even up to like 500 horsepower, in racing situations. But this costs the same amount of money as those. So, and I love Alto High Energy's friction module. I mean, I use them as many transmissions as they make them for anything from stock to all the way up to full race or heavy duty towing and hauling. It's a great module. All right, we're getting 2 new bands put in, so the dual wrap low reverse band and the intermediate manual second band. I always replace my bands in these. The reverse band is sometimes considered a hard part. It just depends on what shop you're working with, but if the pre-existing band's in good shape, a lot of times they will reuse it as long as the drum itself is in good shape. In this case, we had to actually swap out the front planet. So when I say drum, I'm actually referring to the front planet's band surface, and we got a good used one in there and put a new bushing in it, and it's fine. All right, that should cover the broad strokes of the overhaul. I will say it's really, really windy. It's going to be windy today and tomorrow when I'm filming. Unfortunately, I can't put it off, so if you hear a lot of background noise, that is the wind, so I apologize in advance. Other than that, I can't really do much about it. I'll just try to speak up a little bit, especially when the wind's blowing, so that you don't have trouble hearing what I'm saying. All right, we're going to start with the rear gear train and case prep. If you watch the other rebuild, I started with the sub-assemblies first, toward the front of the transmission, but I want to actually start with the rear, and this is how I would recommend that you build your transmission in terms of order operation or sequence of sub-assemblies. And the reason being is you want to know if your reverse servo travel is going to be within specifications. So once we get the gear train built up, we'll go ahead and we'll put it into the case. We'll dial into our rear end play. You want to be between 5 and 25 thousandths on the rear end play, preferably on the lower side of that spec. I like between 8 and 12 thousandths. That's kind of the range I always shoot for. 7 thousandths, 8 thousandths, somewhere in there, 12, maybe 13 on the high end. If I'm beyond 13 thou, I'm shimming it so I can get down below. And the reason for that is when you're doing your gear train end play, you want to make sure that you have plenty of room to work with when you go to adjust front end play, because your rear gear train end play cannot exceed the front end play. Ideally, you want to have about 5 to 7 thousandths greater front end play than you do rear end play, and front end play, the spec is 4 to 22 thousandths net. So that means when you load the gear train, when you net out the little bit of play you have between the input shaft snap ring that secures it to the overdrive planet carrier, there's going to be some movement there you have to subtract. Then after you've netted out both of those, your front end play figure should be between 4 and 22 thou, but you want to have more front end play than rear end play. Because if you don't, if you have more rear end play than you have front end play, then the case is going to bind at points, okay, as all the different parts are moving back and forth during operation. So that's extremely critical. So that's why I like my rear end play on the low side of spec. All right, so this is the TH350 pump bearing. This is a 20,000 shim. We'll try that first. Before we actually do anything with the gear train, we want to prep the case. So that means installation of the rear case seal and the snap ring, and then we'll put the selector shaft in. I have to remove the pinhole seal and put the new one in. And then what we're going to do, once all the case prep's done, we're going to measure the thickness of this 3-tab selective washer that goes in the very back of the case and the 4-tab Babbitt washer that goes on the output shaft flange, and that'll give us a starting point. Okay, now when this transmission came in, it was assembled pretty tight from the factory. Okay, there was not a lot of front end play. It had less than what I usually see. So, we want to keep that in mind. We are replacing the front planet, so maybe that will change things a little bit. But the one thing that, again, if you're new to this, you want to have a couple of things handy, okay? You want to make sure you have a shim pack, all right, for the rear, so you can dial in that rear end play exactly where you want it. And you also want to have a few different thicknesses of selective washer or spacer that goes in on the stator and the pump, because if you're replacing anything in the unit at all, chances are you may have to, I shouldn't say chances are, you may have to use a different thickness washer, and if you don't have one, then the build's going to be delayed until you can get one in. So, they sell them, both the factory spacers and in the aftermarket, of all different thicknesses. You can grab something, a pack or something like that. They're only, I'm going to say, about maybe $20, $30 for a whole pack of them, multiple different thicknesses, 5 or 6 different washers. Okay, use green assembly lube for holding bearings in place, and I also use it to lube the rollers themselves. I'll use the blue assembly lube for your bushings, and then we'll go ahead and we'll install the new lip seals on the intermediate apply piston so that we can finish the assembly of the center support. Okay, we have the new pinhole seal in position. We're just going to use a regular bushing driver handle. And so you just want to make sure you're using something that kind of fits in the inner diameter so that you don't accidentally puncture or bend or damage the seal in any way. Okay, just double check it, go all the way around. I mean, it'll stop when it's fully seated. Now, if you were converting this unit from a 2-wheel drive to a 4x4, what you would have to do is extract the old seal, and then instead of installing the new pinhole seal, you would have to replace it with the cup plug that's installed in the 4x4 units. It is available separately. I'll flash the part number across the screen, but that's what you would have to do. And then from there, you would just simply install a 4-wheel drive output shaft. You wouldn't do anything else really different. I mean, you could reuse your front planet. It doesn't matter if the tone ring's there or not. Now, if you were going from 4x4 to 2-wheel drive, then you would have to go through the extra step of swapping the plug out for this pinhole seal, and then using the appropriate output shaft. But you would have to install a tone ring on the rear planet. I think I said front planet. I'm sorry, rear planet. Okay, the rear planets in these 480Es starting in 1994 for the 4x4 units did not have that tone ring. So if you wanted to go 2-wheel drive, you need that tone ring there, because that is what the rear speed sensor uses as a pickup to send voltage information to the PCM, and then the PCM translates that to a vehicle speed figure. If you don't have that, you'll never shift out of first gear. Okay, now you can see the bushing here. This is a 480E early 91 to 96 pump body bushing. You're going to drive it so it's flush. You can see the little bevel of this bore, it's just barely visible. That's how you want it to seat, because then there's going to be enough here on the underside to locate that TH350 pump bearing so it doesn't come dislodged during operation. All right, that's how you want to handle the back here. All right, now we're going to go ahead and install the rear case seal. So the seal goes in and the snap ring. It's a very straightforward process. First things first, just go ahead and position your rear seal. Get it as square as you can in the bore. Okay, situate it nice and square. And then what you're going to do is find a bushing driver that kind of fits nicely around the seal. but is not bigger than the seal itself. So just get it like so, and then you're going to start tapping it in. Okay, kind of go all around where you need to square it up, just like this. Once you have a little bit of a lip here exposed, you're going to want to position your snap ring, and then using snap ring pliers, you want to install the snap ring into the bore so it sits there, and then you're going to stick your bushing driver on top of the snap ring, and you're just going to start smacking it in until the snap ring seats into the groove, and that's it, you're done. So we'll go ahead and seat it just a little bit further. Alright, now we're going to try to seat the snap ring. Okay, the groove is starting to become exposed on this side, so we should be able to get this thing to sit in the bore voluntarily. Like I said, it's a tough snap ring, so just, you know, you're going to have to deal with it. Okay, it looks like it's on this side. It's in on this side, I should say, but it's not quite yet in on this side. Okay, a little bit more on this side. And that should be good. So just double check it all the way around. I'm thinking right here it's still exposed. Not quite yet in the groove. There we go. Alright, you gotta get eye level with it. I don't know if I'm in the shot, but that's what I'm doing. I'm just kind of crouching down and taking a look. So it's fully installed. Good to go. So just go ahead and lube up the seal and the bushing, because you're not going to have access to it once we turn the case right side up. Alright, if you're wondering how I got this thing out, you know, the old pinhole seal, I just used a thin flat blade screwdriver, went underneath of it here at around 45-degree angle, started smacking it inboard, and then I finished it off with a drift punch. Okay, and it plucked it right out. Again, very simple deal. Some of the stuff, like, you know, little procedures like that, I probably won't show just because it increases runtime, but, you know, a description should be sufficient. It's pretty straightforward. Like I said, most of the assembly process in these transmissions is fairly intuitive, if you will, if you know what the procedure is. Not a whole lot of risk, you just have to follow the directions. That's basically it. If you don't have the ATSG manual for this transmission, you're going to work on it, I will provide a link in the description to a PDF version so you have it. Okay, there's only a few other things we need to do here. So we're going to install the selector shaft seal, and I'm going to install the filter pickup seal as well as the dipstick seal. And that's basically it for case prep. The only other thing you want to do is maybe sand the worm tracks on the case belly down with some 400 grit sandpaper and Durablock. That will allow for any kind of high spots to be knocked down so that you don't run into cross leaks between the valve body assembly and the case. I've already done that with this unit, but it's another step that you want to take prior to assembly. Alright, now I'm going to go ahead and install those other two seals. I will do the pickup seal first, then the selector seal. Alright, so the tool I'm going to use is actually a C6 E4OD 4R100 selector shaft seal installer tool. So I don't have the number, it has long since worn off, but if you search eBay for C6 or E4OD 4100, you know, Ford selector seal install tool, chances are this is what will come up if there's one available. Okay, I use it for all selector shaft seals for GM, Ford, and Dodge, as well as these filter pickup seals. It just fits perfectly inside, and it'll install it nice and square. Okay. If you don't have this tool or can't get it, then just use an appropriately sized bushing driver or even a socket. So for the selector seal, a 15mm socket typically will work. So just get it square into the bore. Okay, and this is another kind of risky area, you know, risky part when it comes to, you know, being new to transmissions or even just in general. A lot of times you may bend the seal inadvertently because it's not quite square, and so you want to maybe purchase a couple extras just in case in the event you damage one, because otherwise you know, you may have to buy a whole other paper and rubber kit, and you know, who the hell wants to do that? But they do sell these separately. All right, let me reposition camera, maybe zoom in a little bit, and you can see a little bit better as to what's going on. All right, I want to double check the seal, make sure it is in fact square. Okay, just have to get eye level with it. And then a few authoritative smacks, and that's it. Okay, looks good. All right, going to reposition the case, get it out of the way so that we begin building up the gear train. All right, so step one here, as I mentioned in the intro, is going to be to measure the combined thickness of your Babbitt output flange thrust washer and your selective steel 3-tab washer that sits right into the back of the case. So we just take our calipers here and we'll do a measurement. Looks like we're sitting right at 153 thousandths of an inch. So 153 thousandths. So next, we're going to take our bearing and our shim. I'm using a 20,000 shim. At least that's what I'm starting with. I did dunk this in transmission fluid, so I want to take this measurement with the bearing fully impregnated with fluid. And it looks like we are at 162, 163. Okay, that's fine. We'll start there. Going to either end up with a 10 thou or a 20,000 shim. And that's just based on what I know to be true when we did the teardown. You know, what I estimated the end play to be. Like I said, it was pretty tight. So, all right, take your low band, your reverse band, and your anti-fretting ring and stick them to the side, because when we install this thing, you know, the whole assembled gear train, we're not going to actually install the band and the we'll put the fretting ring in there, but I'm not going to install the band. Because chances are we might have to do some adjustments. I don't want to take a chance on nicking the band, so that'll go in as the very last thing. The band has absolutely nothing to do or no impact on end play of the gear train. All right, now what you can do, if you want, is take this Babbitt washer, instead of putting it in the drawer, throwing it out, you could stick it right here on your rear planet. Now, if you're working with a 99 and up unit, or actually I think it's 01 and up, sorry, 01 and up, where they changed from a 4-tab to a 2-tab thrust washer there, you can just lop off 2 tabs, and that will be sufficient to adapt this to go on this planet. All right, first thing we want to do is start putting together the gear train itself. So start with your rear ring gear and your intermediate shaft. You notice here we have a snap ring groove. Okay, snap ring groove goes in like this, and just stick it on top. And then let me go grab my snap ring pliers. And all you're going to do is position your snap ring so that it just seats in the groove. And that's it. If you're wearing gloves, you might get caught up. No big deal, I guess. Alright. Alright, now the next thing I want to do is put our bearings in the positions where they need to go. So this is going to be your output shaft to rear ring gear thrust bearing. So it's going to position itself right here. And then you have your sun gear to ring gear inner thrust bearing. That's going to position itself right here. And then this is going to be your sun gear to center support thrust bearing. And this race here, this inner race is actually going to go into the center support. And then the bearing body will thrust against it. And then you have your top hat. And that's going to go there on the sun gear. Alright, so this will go in later. So you can use whatever assembly lube you want on these bearings. And if you had a transmission that came in where it overheated or there was gear train damage, I would replace these bearings. But other than that, you don't really need to. I mean, they will literally last for hundreds of thousands of miles as long as the transmission itself is well cared for. If you're making a mess, clean it up. Okay, so that bearing is done. Work on the next one. Alright, the wind is howling out there, so if you're having trouble hearing me, I do apologize. And if I could, I would just simply postpone this build until Monday or Tuesday when the storm system is supposed to clear out of here. But unfortunately, I can't, kind of limit it on time, so is what it is. Alright, so just smear a whole bunch of this stuff and position your two bearing assemblies. Alright, double check your snap ring, make sure it's fully seated all the way around. Alright, now I'm going to go ahead and position the foot press, because to build up the gear train, we need to have something that'll give us like a cutout. If you have a bench, you can cut a hole in it. I don't like to do that. I like, at least on my assembly benches, I like them to be completely and uninterrupted when it comes to craters and whatnot, but I just use the foot press. So I'll reposition the camera, and then we'll go ahead and begin the buildup of the gear train itself. Alright, now grab your rear planet, situated upside down just like this. Just give it a cursory glance, maybe do a quick check on the pinions. Make sure there's nothing unusual going on, no excessive vertical play, no side play, stuff like that. Make a quick check of your teeth on the ring gear there. So that's going to be the ring gear for your front planet. So with it upside down just like this, what you're going to do is you're going to grab your ring gear assembly with your intermediate shaft and your bearings installed, and you're just going to carefully lower it into position so you mesh ring gear and planet. Okay? Check your bearing, make sure it's there. Now you're going to grab your output shaft with the snap ring. If you haven't done so, lubricate your bushing. And then just carefully mesh the lugs on the snap ring, or the splines rather, with those on the planet, and settle it into position. Okay, this snap ring can be tough. So just go ahead and seat it. If you're wearing gloves, it will like to snag your glove. Alright, now if you're going to reuse that 4-tab Babbitt washer that goes here, and you're having issues dialing in your rear end play, Sonex makes shims that will go underneath this washer. And so you'll have, I want to say they're 5 thousandths and 10 thousandths thick each. and that will allow you to shim this so that you can make micro adjustments to that rear end plate. But like I said, we're not doing that. The TH350 pump bearing shims will serve that purpose. Like I said, we're using a 20 thou shim to start, and then if we need to step down to a 10 thou because we're too tight, we will. All right, now just carefully lift the whole assembly so it's upright. And then what I'm going to do is stick that Babbitt washer that came off the output shaft's rear flange, and I'm going to position it here in the front. And then once the gear train's assembled, before we drop it into the case, what we're going to do is check our travel between the reaction carrier and the output carrier. In other words, the front planet and the rear planet. And if it's not optimal, then we'll need to shim underneath this Babbitt washer here to bring it into where it's acceptable. We want a little bit of play or a little bit of travel, but we don't want an excessive amount of travel where the planets are banging into each other during operation. So if you watched my video that focuses on this aspect of building these transmissions specifically, you'll know what I'm talking about. If not, no worries, we'll go through it here as well. All right, if you have one of those support rings, you could stick it into position there. Okay, next is going to be your front planet. So if you watched the teardown inspection video, you saw that the planet that originally came out of here, the band surface, was completely warped. I mean, it was grooved and ridged all the way around the band surface. So I know in that teardown inspection video, and you may have heard elsewhere, that no individual gear train components will swap between early and late 4L80Es, in other words 91 to 96 4L80s versus the 97 and up. That's actually not true, and that's my mistake for not clarifying. But this front planet will interchange between later TH400s and early 4L80Es up through and including 1998. So if you're having problems, you can't find a planet for whatever reason for a 4L80, but you do have a TH400 front planet, then just know that you can actually install that planet, and this will go backwards too. So that's the only component that will interchange between early and late 4L80Es. Okay? Now, if you want, you don't have to install the planet right now. In fact, I'll go ahead and install the sun gear and the sun gear shaft. So I'll grab those two things. Let me lubricate the bushings. Okay, so here is your sun gear. Note the lubrication hole. And then here is the shaft. Okay, in fact, I want to lubricate the journal too. Alright, so we know this is an early model shaft because it does not have identification grooves on any of the splines. Okay, the later model shafts have those. So what you want to make sure you do is when you install the sun gear, the splines that are beveled like this, as they approach the face of the gear, these face down, so faces rearward in the case. The splines that go all the way to the top like this, that faces up, i.e. faces front when installed into the case. And then the last thing you want to make sure you do is you mesh these two components such that the two lube ports are lined up perfectly. So we'll take a flashlight and we'll double check. Okay. See the light through and through? We have a perfect mesh. Now, if you install this gear upside down, you'll never get a perfect mesh. You'll see some overlap between the two of them. Alright, so bushings are lubed. We'll slide the sun gear and the shaft carefully so that it meshes. And you want to make sure it moves and spins freely. If it binds a little bit, chances are it's because the sun gear shaft bushings are a little tight. You'll need to clearance them. It's not uncommon. On this transmission, the fronts were fine. You know, this front bushing was perfectly fine, but I had to clearance the rear a little bit. It happens. So don't worry about it. I actually show you step-by-step clearancing procedures in either the TH400 or 480E video. I'm not sure which one it was for bushings, but it is in there. Okay, so then we're going to head and mesh. Okay, you just want to carefully mesh. Okay, there we go. I have actually a little too much assembly lube, and that was kind of preventing everything from spinning nice and free, but as you can see, there's no issues. Alright, that's what you want to see. It was a little sloppy, sorry about that, but too much assembly lube will do that to you. Alright, let me go get the support ring that goes in here, and then first we can install the bearing for the center support. Sorry about that. All right, just drop it down. And then when we seat the center support, this race will be turned inboard like this, and then this outer portion here will thrust against the bearing assembly itself. Alright, you have to have this support ring in here. Now some TH400s, they had sprags, low roller assemblies that had support legs built into the roller clutch assembly itself. These roller assemblies are flat. There's no legs or anything like that, so the roller clutch has to be at the correct height so that it can mesh with the race on the center support. Alright, so I'm going to just open up the roller assembly, take it out of the box. And sometimes the rollers will fall out. They get jostled in shipping. Looks like this thing has completely come apart. So this is sometimes what can happen. So let me go ahead and reassemble this thing, and then we'll resume. Alright, we have them all back in except for one, and I just wanted to show you how the little springs themselves are orientated. So if one or more spring mechanisms come out, there's on the inboard side, there's like a little retainer, if you will, and then on the roller side it's kind of flared like this, or bent, so to speak. All right, now these rollers are not directional. You could just put them in however you want, as long as they go in there. And then the assembly itself is going to go with this side facing up toward you. So they will always come out of the box with at least one or two rollers out of position. Unfortunately, just is what it is. So, all right, now I'm gonna grab the center support. We haven't assembled it yet, but I want to test fit it, make sure that there's no concerns. So we're gonna grab our center support thrust washer and that outer bearing race. So all I'm doing is putting green assembly lube on the thrust washer itself. This is not directional either. You can put it in whichever way you want. All right, just like that. Let's make sure it's fully seated. And then your top hat bearing race is going to go here. Just like that. So You want to install this carefully. Let me move the bushing. And when you get your bushing kits, just double check. Make sure that you get a bushing kit for an early 4L80E that has the large rectangular cutout for the lube hole. Let me see if I can get that a little bit better positioned. I don't know if you can see it, to be perfectly honest. But the 97 and up units with the center lube design have a completely different center support bushing. So if you put the wrong bushing in, you'll have a lot of problems. Likewise, if you put the wrong center support on. Okay, so you want to rotate this counterclockwise. And it should lock clockwise. So here we're spinning the entire assembly on the foot press. But it'll freewheel counterclockwise without moving anything else. Hear that sound? It's the sign of a healthy roller assembly. Alright, I'm going to take the center support out. We'll reposition the camera so that we can assemble everything else that needs to go in here, including the apply piston and return spring. And then we'll be ready to take this whole deal over to the other bench where there's a vise, and we will check travel between the reaction and output carrier just to make sure everything's good. There's no way to measure this. I mean, I guess you could with feeler gauges, but there's no spec. It's just simply judgmental. So I'll talk through that when we're over there, but first let me get this thing out of the way, and then we'll do the center support, finish that off, and then we'll get to measuring these two things. Alright, so if you're working on an early 4L80E, you want to exercise a bit of caution, especially if you're new to these units in general. And that is because the lip seal for the outer diameter of the piston for the center support is very similar in appearance and dimension to the lip seals for the forward and direct apply pistons on their outer perimeter. So here's what I'm referring to. Here is the direct clutch piston outer lip seal, okay? And then here is the outer lip seal for the center support. So center support in my left hand, direct / forward lip seal in my right. Okay, they are very similar looking, but they're not quite the same. And unfortunately, at least this kit from TransStar, there's no part numbers on the lip seals. Otherwise, that would make it a lot easier. So you have to look based on appearance, and that's how you're going to have to tell the difference. Now, there is one clue. The forward and the direct clutch apply piston outer perimeter seals, I don't know how to describe this, but they are kind of like glittery in appearance in these kits. Okay, and then the angle of the lip is a little bit shallower. Okay, a little bit shallower, you have to really study them, than that of the center support lip seal. So this is going to be a little steeper, but it's tricky. And so what I tell everybody, and you've heard me repeat this if you watched any of my other rebuilds over and over again, is just keep the old lip seals in place. Because number one, you're not going to adversely affect the ability to clean this thing with the lip seals installed. But number two, you have an immediate reference point. So if you get confused or you're not sure, they're still there. Versus taking them off and chucking them in the trash and then not having any idea, or at least not being sure that you're working with the right lip seals and putting them in the right locations. So that's just my advice. I mean, you know, if you don't want to do that, you don't have to. If you've done these enough, obviously, it's totally unnecessary. But if you're not sure, that's a great way to kind of hedge your bets, so to speak. Because otherwise, these lip seals are very similar in dimension, all three of them. Okay, here is the old inner diameter seal on the new one. You can also see a little bit of wear on the older seals. I mean, like I said, this transmission worked. its only drivability symptom was very harsh upshifts, and we figured out why that was. Just a little bit too aggressive on the drilling of the plate, plus that B&M performance device that the customer has plugged into the vehicle boosts line pressure via the EPC for firmer shifts, and so those two things together kind of created that bang shift issue. And I think he tried to, just flip the switch and keep it stock. As far as I know, or what I can tell from the paperwork B&M puts out for that thing, you have two settings. You have stock and you have performance, and he flipped it to stock, but that didn't really change much of anything. So when we drilled the plate, I left the 1-2 feed alone, and we drilled a 2-3 feed to, I want to say 65 thousandths, or maybe it was that way in the plate already. This is a Transgo plate that we're using on this transmission, and then the 3-4 I drilled to 65 thousandths. So that should give him, crisp shifts, but they shouldn't be jarring. At least I hope not. Alright, so I should have mentioned this, it's obvious, but you want to just align your spring pockets with the cutouts in the support. Okay, a lot of people ask me where I get this lip seal installation tool. Whatever it takes transmissions or WIT Performance transmissions sells these. They are on eBay. You can buy them there. You can also call WIT Performance. I think they'll sell them to you directly if you want, if they don't have anything on eBay. So it's a very effective tool. They have lip or loop style tools as well, and then the Transtech kits will come with like a circular flat style lip seal tool. That's actually not that bad. I've used it a few times, and it works. But this knife-like tool, or blade style tool, is the best kind that I've used, or my favorite kind anyway. Alright, this does take a little bit of time to get seated. The main thing is you don't want to cut the lip seal. I mean, that's self-explanatory and obvious, but it's actually fairly easy to do if you try to force anything. So a little bit of downward pressure, and then just go all the way around. Try to turn it. There we go. Okay. As long as you don't feel anything hanging up when it goes in, you should be fine. Alright, this is fairly easy to install. Of course, when I say that, watch, I'll screw it up. But this is something you don't need a press for. So just press down on the body of the return spring, and then just go all the way around until you see the snap ring into the groove. And like I said, if you're wearing gloves like me, you do run the risk of catching the glove in between the snap ring and the body of the return spring assembly. So just go at eye level and check it all the way around, make sure it's actually in there. Okay, you can leave off the sealing rings for now. You can install them after, after we do our check with the planets. For now, I'm just going to leave them off, and then we will install the Teflon sealing rings instead of the interlock rings, because they're technically correct for the 91 to 96. The 97 and up, they have you use these rings. That was what GM switched to, but either style of ring will work on any TH400 or 480E center support. Alright, I'm going to put this back on the rest of the gear train, and we'll take all that stuff over to the other bench with the vise, and we will check the travel between the reaction planet and the output planet. Okay, so we have everything set up in the vise, and all you need to do to check this is to take both hands, put your fingers underneath the front planet, and then while you're holding the center support in place with your thumbs, you're going to just simply lift up on the front planet until you hear it come into contact with the center support. All right, so the very first thing that I'll do is take a screwdriver and actually seat the front planet all the way on to the rear planet, as far down as I can get it. And then I'll lift up. And back down. Up. Back down. So this is optimal travel. There's nothing we need to do here. All right, we're back at the bench. I'm gonna remove the center support. So just lift up on it, rotating counterclockwise. And then grab the sun gear shaft so it doesn't come up out of position. And then you wanna check this low roller. If you had rollers come out, I don't know if this was visible in a couple segments ago, but I was actually missing another roller was sitting on the bench. So you always want to double check this kind of stuff. But you could tell if you're missing a roller by just simply going all the way around inspecting each of the roller locations. So just something I wanted to point out. If you noticed it, this way you'll also notice that I noticed it and I put it back. All right, I'm gonna put the center support back in. And with respect to the ceiling rings, you really don't need to put them on until you're ready to install this thing for the final time. So if you want to leave them off, you can. No big deal. So what I'm going to do is I'm going to put the gear train on another bench real quick so that I can get the case back into view, and then we can do what we need to do with the case. So again, you're going to leave the reverse band out of the case for the purposes of setting up and adjusting and checking your end play. Only when you have that end play dialed in would I suggest you install the low reverse band. We will put the anti-fretting ring in there, that has to be in there, but the low reverse band can stay out and the ceiling rings can stay off until you're done with your end play measurements. Alright, now we're ready to begin our prep and installation of what we need to go ahead and check rear gear end play. So first thing you want to grab is the anti-fretting ring. It's just the thinnest of the 3 snap rings that are in the rear of the case. Okay, it's got 2 pointed ends just like this, and you can just stick those ends facing the 9 o'clock position and just settle it into the groove. Okay, it needs to go all the way onto that rear case surface down here. Okay, I got it in one of the snap ring grooves for center support. So that's how you want it. It needs to be on that bottommost ledge right here. So just check it, go all the way around. Hopefully my arm is not totally in the way. All right, now you're gonna take your bearing and we're gonna start with a 20 thousandths shim. And you're going to install the bearing like this, okay? If you install it like this, then the inner portion of the bearing is going to be rotating and thrusting against the bushing. And eventually, it's going to cut the bushing. So if you install it like this, the inner portion that's located onto the bushing is going to stay largely static, and it's going to be this outer upper portion that rotates instead. All right, now, I should have mentioned this earlier, and I'll annotate so that there's no confusion, but before you install that rear case seal and snap ring, you want to just check this bearing and the 20 thou shim. Make sure that there's enough protrusion in the bushing to give you a good solid location for the bearing. If it's not deep enough, then you're going to have to drive it in a little deeper. So I just go like this. That's a good way to check. If it doesn't come off easily or at all, then you're fine. All right, now we're in position to actually install the gear train. So we're going to set the gear train in, and then we're going to install the snap ring for the center support with the beveled side facing up. All right, we're not going to install the feed bolt. Okay, the feed bolt that goes in for the intermediate clutch, we're going to leave that out. All right, don't install that. So, and again, we're going to leave the band out. Now, to hoist the gear train assembly in safely, you're going to need some sort of tool. Okay, I have this thing. It's a specialized tool made specifically for, raising, lowering, handling, hoisting, lifting the gear train assembly, and it goes right underneath the underside bevel of the intermediate shaft. You can use vice grips for this too. If you're familiar with automatic transmissions, Hiram Gutierrez, he has a 4L80E video reassembly where he uses these vice grips that I see used typically in welding, but he'll use them to hoist that whole assembly in, and he does it safely, but you just want to be real careful if you're not going to use this special tool. Special tool's like 30 bucks. I think you're going to pay the same amount for the special tool as you would for the pair of vice grips. And so I would just buy the special tool. All right, just make sure that your feed bolts are oriented at the 6 o'clock position, and then that's basically it. All you're going to do is just carefully hoist it into place. Okay, I'm lined up. So now I'm just going to grab the snap ring. Just situate it. And with the tripod in the way, this is probably going to be a little bit clunky. Dealing with the tripod and the little lamp. All right, now I got to move the camera again because we have to set up a dial indicator. And what I'm going to do is I'm going to position the plunger right here on the output shaft, the intermediate shaft. And then what we're going to do is take a screwdriver, a big, long, thick one, not the one you just saw, but a different one. And we're going to thrust upward, okay, lever upward on the entire gear train from underside of that output shaft flange. And that will give us a reading and tell us what we're where we're at with respect to rear gear end play. All right, I have the dial indicator in what I think is a stable and steady position. So we have a contraption here. I'll do a kind of a zoom out to show you, a better look at it once we're done with the check. But you just want to make sure it is zeroed. And then we're going to take our screwdriver and we're going to lift up on the output shaft flange so that we can measure how much travel we have in this gear set. All right, so like I said, I'll kind of zoom in on the contraption, and then I'll show you after we're done with the check itself where I'm inserting the screwdriver. I mean, you already know if you're either A, familiar with these transmissions, or B, you watch my other TH100's 4L80E rebuild series videos, because it's the same place and the same procedure for every one of them. Okay, I'm getting 4 thousandths. Actually, it's not returning to zero, so it might be 3 thousandths. Yep, that's 3 thousandths on the indicator. Three 4 thousandths is obviously too tight. So when we go back with it, I'm going to install that 10 thou shim and we will see where we're at. So let me do a quick zoom in, zoom out so you can see how everything's set up in the case, and then I'll show you where exactly I'm sticking that screwdriver. Alright, so here's the whole setup. This bolt, I think it's a sway bar suspension link bolt out of an F-body, specifically my Trans Am. I had replaced the sway bar linkage and all the bushings and stuff, and it came with hardware, so I'm almost positive that's what this bolt is. And it just happens to have the same threads as the pump to case bolts. All right, and then you have this other thing, which is a Kent Moore tool. I'll annotate the video with the specific J number, and then a Starrett dial indicator just set up as you see it. All right, now I'll show you where I'm sticking that screwdriver so you know where that needs to go. All right, so all you're gonna do is take it, kind of maneuver it carefully into this corner right here. I mean, you can go on the right side too if you want, but then all you're gonna do is just lift up, just like that, until the indicator stops moving. And that's it. All right, let me reset everything, get that gear train out, and then get a different thickness shim in there, and then we'll check it again and see where we're at. All right, everything's back in. Perhaps third time will be the charm. Got 10,000 shim, so just want to double check the indicator, make sure it's on 0. And let's see what we have. I'm going to tilt the case back just because there's a little slop in the fixture, or the stand rather. Hey, we're at 9. Okay, it's returning below 0. Hey, everything's moving now, so get it back to 0. 9 thousandths. Back to 0. 9 thousandths. All right, I'm happy with that. So for front end play now, we just need to be greater than 9 thousandths. So I'll shoot for somewhere between, let's call it 15 and 20. 15 and 20 thousandths for front end play. That'll be kind of our target zone. So we know spacing between the front and rear planet are good. We now have verified that front end play is good. So now, rear end play is good. We need to then take a measurement for that snap ring and the input shaft against the base of the rear planet, because there'll be a gap between the snap ring and the base. And then we'll start messing with our front end play once we have the case full and the pump ready to drop in. Okay. All right, now we're gonna remove the gear train, set it aside. I'll put the center support on the bench. We'll install our Teflon sealing rings, and then from there, we'll be ready to install everything in the rear of the case for the final time, including the band, which is soaking in transmission fluid right now. All right, center support's on the bench. So we're gonna now install our Teflon sealing rings. If you don't have the special tool that's used to resize these rings, and this is the tool in question, it's going to be Kent Moore J38736-7. Do not worry about it, okay? Here's the sizer for the one-piece Teflon sealing rings on the stator. For the pump, that's J38736-7. All right, if you don't have either of these tools, do not worry about them because you do not need them. So first off, you have your interlock type sealing rings. They will work in retro to any year 4LADE or TH400. They're intended for the 97 and up, but they'll work on any center support for that transmission family. Okay, now if you want to run the Teflon one-piece sealing rings, and for high performance, you want to run them. These are better than these when it comes to real high RPM, high pressure situations. You can spend maybe $10 to $15 and get yourself a package of these rubber sheets. Okay, they're 6x6 by 1/16 of an inch, 3-pack, on Amazon for like $10 shipped, and a 50-cent hose clamp. And all you're going to do is cut a length that corresponds to roughly the diameter of your sealing ring. Okay, and you're going to situate it in here just like this. And then the sealing ring will fit in here, okay, just like this when you go to install it. In fact, I'm a little tight. So it'll sit in here and you'll be able to size this thing perfect. And this will work on any transmission. I mean, if you have a one-piece Teflon sealing ring, it'll work. Okay, just get the appropriate length sheet, little strip, and the appropriate diameter hose clamp, and you'll be good. Okay, all these ceiling rings come in the kit. When you install them, you just want to be careful. I'm using a 45-degree angle pick. And you just want to maneuver them and kind of expand them a little bit. There is a special tool to do this as well. But again, you don't need it as long as you're careful. I mean, that's really the main thing. You just want to be careful. So I'll situate it in the groove a little bit, just like this. And then I'll gently expand it until I can get it so that it's going to slide over. And I'll just work it back and forth. I mean, I'm being kind of clumsy with it, but you get the idea. Okay, you don't want to expand it too much because then it'll never resize right. But you just have to expand it enough so that it gets over top and starts sliding down the stator. Okay, once you have it, then you could just go and carefully maneuver it over the ceiling ring grooves until you get to the very bottom groove. It looks like I'm going to need a new glove. Do the best you can to size it by hand. And then go ahead and expand your little tool here. And then what I want to make sure is that for the clamp area, okay, I don't want any gaps. I want to make sure that the two ends of my little length here, little rubber strip, are facing away or located far away from the clamping mechanism. Alright, so just situate it and then start cranking down on it. Okay, what I try to do is I want to make sure that this rubber strip is, kind of seated on the very bottom of the support. Because that's how I know that it is all the way around that ceiling ring and it's not going to cut it or there's not going to be a problem. Okay, this little handle is actually somewhat interfering. I'm only going to do this on one. I'll demonstrate it on this one, and then I'll do the rest off camera just because of runtime. I mean, you've seen it once, you get the idea. Okay, just tighten it up and let it sit there for like, I don't know, 2-3 minutes. That should be it. And then you'll be good. And incidentally, don't lose track of your thick screwdriver. When you go to measure front end play, you're going to need this to load the rear so that you can get a net measurement at the front. Alright, it's been about 3 minutes or so, so let's check it and see if there's anything that we have to do, any additional sizing that has to take place. Alright, I'm going to grab my direct drum. Okay, you want to leave the drum on too. The drum will be like your final sizing tool, so leave the drum in place for maybe another few minutes or so and then check it. Okay, make sure it's spinning nice and freely in the groove, and that's all there is to it. So let me install the rest of these, and then we'll resume building up the direct drum so that we can then air test this drum with the center support on the bench. And once we've done that, we've confirmed that the the direct clutch is working as it should. We'll go ahead and install the center support back onto the gear train and install the gear train for the final time so we can then check our servo travel. Alright, we have all of our ceiling rings installed. So at this point you're probably wondering to yourself, do I even need this whole hose clamp and rubber strip contraption? Can't I just use the direct drum as my sizing tool for these one-piece ceiling rings? Short answer is yes. Yes, you can. You can use the direct drum for these rings, and then you can use the forward drum to resize your one-piece sealing rings on the input shaft. So when it comes to special tools and trying to determine if you should spend the money and the time it's going to take to acquire them, it's really just simple cost, risk, benefit proposition, right? So cost plus risk must always be less than benefit if you're going to make the decision to purchase something or do something. It doesn't matter what it is. So if the cost of not having the tool, okay, in terms of the risk or in terms of the time it's going to take you to use alternative methods that may require a bit more care, thus take a little bit longer, if that is less than the benefit in terms of the savings in money and time it would take to acquire the tool, then you don't buy the tool. If you're a DIYer and this is going to be the only transmission you're ever going to build, then chances are that cost benefit proposition is going to favor not buying the tools. Okay, you're spending, I don't know how much these Kentmore tools are going for now, but maybe you're spending over $100 on a sizing tool you're going to use once, maybe twice. So again, cost, risk, benefit. Is the benefit and the net value there? Probably not. So, especially considering you have these rings. And again, if you're a DIYer, chances are you're not building your first transmission to handle 600, 700, 800 horsepower or whatever. You're just trying to get your vehicle back on the road. So, anyway, now what we're going to do is build up the direct drum, because we want to make sure that the direct drum and the direct clutch specifically is good to go, and we need to have the center support out so we can do our air check and measure the clearance. Alright, first thing I want to do is actually install the sprag assembly. So we have our interlock ring, or spiral lock ring rather. This is going to be our top plate, and then this is going to be our sprag. So sprag rotation in these is going to be freewheeling clockwise, locking counterclockwise. And the reason for that, or at least the relationship between the direction of freewheel rotation on any one-way assembly and the clutch basket, is such that this is true for most GM stuff for the intermediate sprags. If the clutch basket, okay, this is the clutch basket, okay, if this is facing front, then your one-way assembly is going to freewheel in clockwise direction. It's going to lock counterclockwise. Now, if you're working on a Ford transmission like a C6 or 4100, okay, the direct drum clutch basket is oriented facing the rear. Okay. All right, the battery literally was about to die, so I had to swap it out real quick. But as I was saying, sprag rotation is largely based on orientation of the clutch basket. So for most of the GM transmissions and intermediate sprags, for the units that take them, your sprag rotation is going to be freewheel clockwise, lock counterclockwise. For Ford, it's going to be in the opposite direction. It's going to freewheel counterclockwise and lock clockwise. All right, and I'm not going to lie, almost invariably I get this wrong. So in other words, I install the assembly upside down. If you do that and you don't catch it, then you're not going to have any second gear. It'll be neutral. Or if the sprag rolls, you'll be neutral. Okay, so if the sprag rolls over and fails, you cannot reuse this and you cannot reuse this. You have to replace both of these things. So it is kind of a costly deal. And yeah, I think this is on upside down. It is kind of a costly deal because all these things have to be replaced. You can't just replace the roller element itself, or the the one-way clutch element. So I'm basically trying to collapse the rollers inside the outer race. Now you want to have it fairly square. And I don't know of any special tools that allow you to do this like super quick, but you don't want to force anything. You want to just ease it over until it seats. Okay, so freewheel clockwise, locks counterclockwise. Okay, and obviously the side with these parallel grooves going all the way around faces you. Okay, get your plate, and then you want to make sure that that snap ring groove's fully exposed, and then you just want to start easing in your spiral lock ring, and you'll notice that there's two positions that this thing is going to lock. Okay, you got a locking tab and a slot, and then you have a locking tab here and a corresponding slot. Sometimes it's kind of a pain to get it in. So if I'm fumbling around with this thing for any length of time at all, I'm going to just shut the camera off, and then I'll bring you back when it's all in, and I'll just kind of do a close-up so you can see exactly how it looks when it's installed properly. Okay, so here's our other locking tab. I know the hazards of using gloves. Okay, that is not in yet. Okay, sometimes you have to reset it. In fact, I'm going to check this, make sure it's locked. Okay, if this lower tab here isn't locked, then you're never going to get the upper locking tab in place. Because you'll hear a positive snap when it actually fully engages, and that's how you'll know you're good. Okay, so what I'm going to do is I'm going to use these little cutouts to try and engage the tab. Give me a little bit of room to work. Alright. The lighting sucks, but both of the tabs are in. So Sprag's good to go. So now we're gonna go ahead and install all of our clutches. So first we need our our piston and our 3 lip seals. So the drum seal on between the Ford and the Direct in these early model units, they're dramatically different in terms of like diameter wise, visually. You'd be very hard pressed to mix them up. So the lip faces up when you install these seals. Now if you were dual feeding this thing, then what you would do is you would leave out the drum seal itself, okay? You would not install it at all. And then you would still install your lip seals on the piston, but then on the center support, you would leave out this second from the top sealing ring, okay? You would just leave it off. You would install 3 sealing rings only, okay? And then on the case, you would plug the reverse high feed passage. So it's going to correspond to this feed passage right there. And that's it. That's all you would need to do. So we'll go ahead and lube up our sealing surface. You just maybe want to take a quick check. Make sure that everything's good to go. There's nothing unusual that maybe you missed during your final inspection of these parts, like, you know, scoring or cuts, you know, whatever in that area of the sealing, you know, the diameter here on the inner portion of the drum. Same with the sealing surface on the inside. You just want to check everything, all right? That's all. That was a very sloppy way of saying that, but it's kind of how I roll. All right. So your lip seal, the sealing surface is here. It's going to face up. It's going to face you. Just get it in the groove. Just go all the way around. Make sure it's not twisted. Should be able to rotate it freely. Okay. And then we'll go ahead and we'll install our sealing rings. So we have lip seals. We have our old lip seals installed. On the early model units, I do not see the word direct cast into the piston. However, this portion of the piston here is wider. This is the crown. We'll call it that. This is wider on the direct than it is on the forward. So I'll just show you real quick. Okay, the direct clutch piston is in my right hand and the forward is in my left. And as you can see, just visually speaking, this is clearly wider in this area here. So the other telltale sign is the word forward is cast into the underside of the piston. So you'd have to go out of your way to mix them up. But if you're not paying attention, then I guess it's possible. But, you know, GM for the most part does make it easy for you, at least with these transmissions, to be able to tell the two apart. Okay, this thing wants to be stubborn. It's stubborn because it's a little bit hardened, and if you watched the teardown video, we saw that the clutch pack in this drum was a little bit stressed. It wasn't burnt, not by any stretch of the imagination, but it was a little stressed. And both of these lip seals are not perfectly supple. They're a little bit hard, just starting to go bad. So if he hadn't brought this in for refresh, he probably would have had another, maybe, I don't know, anywhere from 5 to 30,000 miles. I mean, I know that's kind of a huge range, but that's when I'm estimating the amount of life left based on what I've observed. So here we're going to kind of reset the clock completely on all the soft parts, you know, lip seals, sealing rings, O-rings, friction elements, meaning clutches and bands. Same with the steels. So just lube everything up. Get everything nice and liberally soaked with assembly lube. Like I always say, you can't use too much of this stuff. You can only use not enough. And then I should have mentioned it earlier, but you just want to make sure that this bleeder ball is functional. Okay, if you're not sure, you can take a pick and just move it around. Okay, very rarely are these bad. Okay, they'll usually make noise. I installed the sprags, so it's not as obvious, but it is moving. So if you have an issue there, these will want to come on when you're not supposed to be in third gear. So okay, go all the way around on this inner seal first. Make sure that it is fully seated. And then start working the perimeter seal. You know, a little bit of downward pressure. Just go all the way around, turn it slightly. You know, just kind of rotate it clockwise. And if you're hung up, you know, just kind of reset and try it again. You don't want to force anything with lip seals. If you cut them, you're back to the transport supplier for a whole new overhaul kit. To my knowledge, actually, you know what? Before I say something that's wrong, I'll correct myself here in real time. There are a couple of transmission part suppliers online that will actually sell you lip seals individually. I was going to say that you couldn't get them individually, but I can't get them individually locally, but I think Global Transmission Parts sells these individually for like $1.50 a piece. Alright, that seems to be in there. So I'm going to go to the foot press, install this snap ring, and then we'll come back and we'll fill it with frictions, and then we'll measure clearance. Alright, so when you're installing your snap ring, what I've been doing lately, because that's just something I've noticed the factory doing, is they will have the end of the snap ring here right in line with one of the locking bosses. So that's how I'm positioning this one. So you could use a foot press, you could use a bench mounted press, you can use like an arbor press. I mean, it ultimately doesn't matter as long as you have something. Alright, so make sure that your return spring assembly is perfectly lined up. And looks like I'm probably not perfectly aligned. There we go. So you want to make sure that you're perfectly aligned, otherwise you're never going to get the snap ring in. Okay, just like that. Alright, we'll go back to the bench and finish this up. Alright, as I mentioned, we're going to be installing some high energy frictions. So here is the clutch pack. So we're going to have our cushion plate. The dish faces up, or the cone faces up. Okay, so it goes like this on the bottom steel. That's how it came out. That's how it's going to go back in. And then you have your steels and your frictions. 80 thousandths on the frictions, 90 thousandths on the steel plate. Now it looks like 93, 94 thousandths. Like 80 thousandths, maybe 81 thousandths. Okay, 50 to 60 thousandths. So general rule of thumb with all GM transmissions, or really all transmissions, period, is unless the diameter of the clutch is enormous, generally speaking, you want to stick to 10 thousandths of an inch of clearance per friction in the clutch pack. Okay, these cushion plates are brand new. They came with the steel module. I recommend that you purchase new cushion plates if you're going to run this style. And a factory to mild performance deal, it's not, there's no concerns. I mean, unless they're defective or there's some issue with the metal, they're not going to break. But anything real high RPM, high performance, I actually don't run anything in here as far as cushion plate. Okay, there is some differences between the early and late 4L80s, the 91 to 96 versus the 97 and up. In terms of like clutch stack up, and in the case of the intermediate, the thicknesses of the frictions themselves. I mean, I'll get more into it when we get there, but the late model units have 70 thousandths thick intermediate clutch, intermediate frictions, and the early stuff comes with 80 thousandths and no cushion plate, and the pistons are also different. This piston is the same piston that was installed in the TH400 center support starting in, I believe, 1988 or 1989. They moved over to this piston here, and they carried it into 1995. 96 and up, they have a different piston, or at least there's a different casting number on that piston. Dimensionally, I'm not 100% sure if it's different or not. I'll have to do some measurements or whatever at another time, but that's the story. So I'm going to turn the compressor on. We're going to work this clutch, kind of get it moving, make sure it does apply, there's no issues, and then we'll set up the dial indicator and we'll go ahead and do a clearance check. Now we have to take the backing plate off so that we can measure the depth from the ledge that this thing sits on to the top friction, and we have to add that to the travel between everything up until where the snap ring is fully seated on the top side of the groove here. Okay, just make sure everything is fully seated. Okay, it's like there was one sealing ring there that was holding things up, but we're good now. let me turn the compressor on and we'll do an air check. All right, now we're ready to go ahead and do a quick air check. So you want to apply air into the direct clutch feed and then the high reverse feed. When you apply air into the high reverse feed, you want to plug the direct feed, otherwise a bunch of air will be whooshing out. These in the TH400s, the direct drums are dually fed when in reverse, but not in direct. I mean, kind of dumb. I wish GM had just made them from the factory such that both third and reverse had, dual feeds, 2 apply circuits basically, but it's not the way they set it up. So anyway, go ahead and check direct first. Okay, we just want to make sure we have a good seal. Okay, very positive apply. And then we'll go ahead and we'll do our high reverse. So I have to switch hands. All right, good to go. All right, I moved my thumb off, but you get the idea. So we want to get the clutch working a little bit before we measure our clearance. So let me set up the dial indicator here. I like to put it on a pedestal in the back. And then what we need to do first is take the snap ring and the backing plate off so that we can measure that distance between the ledge where this backing plate sits and the top friction here. Okay, so it's this ledge. There's going to be a little bit of a distance between the top of this ledge and the top friction. It's not going to be much, but it'll be there. Ideally, we want to see between 50 and 60 thousandths clearance for this clutch. All right, so set up your pair of dial calipers so that you have the plunger extended a little bit. And then what you're going to do is come in like this, get this firmly against the wall, and then collapse it until you hit that ledge. And then let's see what we have. Looks like 20 thousandths. Run it back. $15, but I don't like that. That was sloppy. Yeah, give it 15 again. $20. So just go around. I like to do it in 4 spots. Just gives me a good average. That's 22 or 23. And same. I know there's a lot of glare, so sorry about that, but I'm going to call it between 20 and 22 as, our measurement there. Alright, let's move that indicator into position. And I just want to make sure that it's straight up and down. Okay, the indicator's at 0, appears to be stable. So let's see what our travel is between the ledge and the snap ring against the top portion of the groove there. It's like 36 thousandths. 36, 37. So this is telling us we're between 55 and 57, maybe 58 thousandths of an inch. That's perfectly fine. Clearance, once this goes into the vehicle, will open up a little bit. You know, once the elements are all working together and they've kind of quote unquote broken in, you'll see maybe an increase of a few thou. Fluid will take up some slack as well, so the difference is not going to be as pronounced. But that's, you know, from what I've seen, that's been, you know, that's been my experience, I guess, with deltas in clutch clearances between bench measurements and, you know, when they were put in the vehicle. And I only know that because of the few comebacks I've had. I have actually taken measurements of clearance, and they've all been between 5 and 10 thousandths higher or greater than when I put them in. So that's why I like to be on the tighter side, generally speaking, unless it's prudent to be on the looser side. If you go aim right for the middle, like 55 thousandths, I mean, you can't lose. 50 thousandths, that's fine too. If it was like 40 thousandths, I would probably make some sort of adjustment to get me a little bit more clearance, but for a stock application, this is fine. Okay, now that we've gotten our clearance situated, these two don't want to let go of each other. I'm going to go ahead and install the center support back onto the rest of the gear train. We'll drop the gear train in for the final time. We got to put the low reverse band in, then we'll put the gear train, and then at that point we'll go ahead and install the new intermediate feed bolt. All right, so hopefully this view is sufficient. If your fretting ring is still in there, just go ahead and take it out for, you know, a few minutes while you situate the band in place. So I don't soak my frictions, but I do soak my bands. Okay. It's probably not necessary to soak either of them, because when you start the vehicle up, assuming you fill the transmission to the proper level or close to it, you'll have more than enough lubrication just at idle to make sure that all your applied elements are adequately soaked in. And all you really need to do is let it run for about, I don't know, 30 to 60 seconds, maybe a couple of minutes, and then shut it off and walk away, go eat lunch or whatever, dinner, and then come back. And then from there, the frictions will have plenty of time to soak in all that clutch fluid. You just need to make sure they're adequately soaked before you put them to work, not necessarily when you install them into whatever part of the transmission they need to go in. So these band anchors obviously need to go onto the band anchor pins, and then you want to make sure that your apply point is, you know, lined up with the servo bore for your low reverse. Okay, I hate getting my hands dirty with fluid, so just kind of tap the band down on in. Okay, it'll eventually go, especially if you're better at this than I am. All right, again, hopefully I'm not sticking my fat head in the way, but unfortunately I'm going to have to, so that I can verify that the positioning is correct. I mean, it's not going to take you anywhere near this long to seat this band, unless, of course, you're filming it like I am and you got a big tripod in the way with a camera on top of it. Alright, what I like to do now is take a Phillips head screwdriver. I'll come into the servo bore for the band, and I'll seat it so that it's fully against those anchors. And then I'll just tap it all the way around, double checking, make sure that it is where it needs to be. Okay, it appears to be in position. So the band does not have to come out unless something else goes wrong. The band will stay in there. The anti-fretting ring, which we'll now install or reinstall, will stay in there permanently, so will everything else. Okay, I'm orienting the openings to the roughly 9 o'clock position. And this is generally how I do it. I mean, I think when I took this thing apart, the end of the center support snap ring was either here or here. I can't remember, but it was offset toward one of the sides of the case lugs. Alright, so I'm going to try to show you something real quick. Just a tip for alignment of your center support. So you see I colored the little lug there that's kind of triangular shaped. I colored that with a Sharpie. You want that lug to the immediate left of this lug here at roughly the 8 o'clock position. Okay, I don't know if you can see that. I guess I won't know until I go to do the edits and all that good stuff, but you know, that's what you want to have happen so that you know your bolt holes are lined up with the ones in the case. Bolt holes in the center support, bolt holes in the case. All right. Spin the output shaft, clockwise, counterclockwise. All right, what you're trying to do here is just make sure that nothing got caught up, nothing's dragging, nothing feels weird. You know, just a typical check before you move any further and put yourself in a position where you got to take stuff out again. So that's a little biased, more so than I like. So I'm gonna reset it. So like I said, I like to keep these ends roughly at the 9 o'clock position. So make sure the beveled side of this snap ring is facing up, facing you. Okay, so you can easily tell if the beveled side is facing up. You don't want to install it upside down. Alright, now we're going to go ahead and install the center support feed bolt. I'm not going to torque it at this time. Back here, I'll just reposition the camera so you can see it, because you're not going to be able to see much of anything with the way it's oriented now. So the socket I'm using is going to be snap-on. And it is you can see that I can't even read it through the glare. GSF 121. GSF 121. Probably not more than 10 bucks if that. So these things get like 34 or 36 foot-pounds of torque off the double check. But we're not going to torque it to spec now, we're just going to install it. So just run it down until it more or less comes to a stop and you're good. If for whatever reason your kit does not include a new feed bolt, unless there's something really wrong with the other one, you know, there's not too much in terms of risk of reusing it. All right. In 1988 or 89, The TH400 case has changed, and they went to a longer feed bolt, much like what you just saw. Okay, so that necessitated some other changes to like the support, and like I said, the piston changed. So if you're working on a later TH400, just know that there may be some parts in this general area that may or may not interchange individually with earlier TH400s, but will with early 480Es. Alright, so now that we have the gear train in for the final time, but nothing else in the case, what we're going to do is assemble the low reverse servo. So we have our apply pin, our lower spacer, or spring stop rather, the spring itself, our washer, and then our E-clip for retention. So you'll need an additional test gasket, if you will. So I'd recommend you purchase an additional one loose with your rest of your kit. These are a couple of bucks at most. Otherwise, these are basically single use only, and the sealing surface here, once it's collapsed, that's it. You know, you're basically done with it. So all these bolts get 18 foot-pounds of torque, and what we're going to do is we're going to assess the servo travel based on the assembled apply piston, and we're going to measure how far this servo travels into the bore at full bind. In other words, where it's, you know, got the band fully applied and you can't push it in any further. All right, once we assess that travel, assuming that it's within our required target range, which is between 100 and 175 thousandths of an inch, we're going to bolt this test gasket and the cover over the servo, and we're going to see if there's any drag at all. On the higher end of the range there's almost, like, you know, the chance is basically zero that there's going to be any drag. But on the lower end of the range, we want to check because maybe there's a little bit of drag, or, you know, there's a chance that that may happen. So in my other video, assembling 480E as well as both TH400 rebuild series, I did this step in the process after the case is fully assembled, but you really don't want to wait that long. You want to do it with the gear train in and nothing else, because it'll give you a much better feel for what's going on inside the case, and you'll be able to tell if there's any drag a lot easier without the rest of all the components in there versus with the case fully loaded. So, alright, assembly is very straightforward. So you're just going to take your spring stop, that's going to go here, and then your spring, and then your little washer, okay? And then you're going to insert all of this into the servo. And sometimes the pin bore can be a little tight, so you may have to jostle it a little bit or persuade it on the bench. I mean, like I said, you don't want to force anything. So if it's not cooperative, just, you know, either reset or, you know, try to just like finagle it. And what you can see here is there's like a little lip forming. Unfortunately, that is par for the course with these things. So I'm just going to gently, and I mean gently, tap on it with a hammer just to get it past that lip. Okay. All right. Once I could feel the spring kind of pushing back on it, then I know I'm good to install my E-clip. And I just realized I'm not in the shot, so let me get in the shot. Kind of have to be quick with it because that spring is going to want to push back and, you know, kind of close off your access to the snap ring groove there. All right, I'm going to reposition the camera on the case so that we can begin the check itself, and I'll show you exactly where you need to measure this thing so that you're getting an accurate reading. All right, we're ready to test fit the servo assembly and see how far it travels into the bore before it fully applies the band. Now, most instructions for this procedure are going to tell you to leave your seal off, but I found that keeping it on actually helps you a little bit, because once the seal is in the bore, it'll kind of offset a lot of the pushback that this spring is going to give you when you're trying to fully seat it by hand so you could take a measurement. So just lube your seal up really, really, really good. And same with the bore itself. You know, just use a ton of assembly lube. Go ahead and lube the 1-2 accumulator bore, because when we're done with all of our testing and evaluation here, I'm going to install everything into this bore for the final time, and we'll be done. You know, we'll conclude with an air check just to make sure it works, but we'll be all done basically with the servo and 1-2 accumulator at the back of the case. So, all right, now this is going to take the better part of, if not all, my weight. So I'm going to have to stand on it. So basically what I'm going to do is I'm going to grab my dial calipers and I'm going to extend the depth plunger just, you know, enough. And what I'm looking for here is between 150 and 175 thousandths. I think it's at 100 thousandths on the bench when I was putting this thing together, but it's 150 and 175 thousandths. I've seen as high as 250 actually still works. So you have some latitude, but if you're in that range of 150 to 175, or let's just say 200 thousandths on the extreme high end, then you will have ideal band clearance and servo travel. All right, I'm gonna put a glove on, another glove, because there'll be a little bit of space opening up between that E-clip and, you know, the underside of the piston, or underside of the pin rather, and it'll get caught up in my rubber glove. It's happened before. All right, so what I'm gonna do is I'm gonna press down on this with all my weight. I'm actually just gonna stand on the stand itself. Go all the way in, and as you can see, the output shaft moved a little bit. So that means that I am on the band. Alright, so I'm getting 80 thousandths of an inch. Actually, that's 77 thousandths. So I'm going to try again. Always like to take 2 or 3 measurements here, just to make sure that I'm getting the consistent reading each and every time. And I'm measuring here between these 2 hash marks. 80 thousandths. 80 thousandths is a bit too tight. So if I were to bolt this assembly in place, I would get a ton of drag here on the band. Okay. So right now, obviously there's no drag because there's no piston in there. It should feel very similar to this when you have the piston and everything fully assembled and the cover installed, torqued to spec, because that would indicate there's no drag. And then when you apply air at this location right over here, then you'll see the output shaft move, and you will see the band apply and grab the drum, well, the drum surface of the planet. And that's what you want to see. Okay, so what we're going to do is I'm going to grind on this tip incrementally until I get to about 150 thousandths, and then I'm going to stop. I'm going to install my test gasket, the cover, just what you see here, you know, no accumulator, piston, or spring, and then I'm going to assess the, you know, drag or lack thereof. But I know for a fact I'll be dragging, and if you watch the teardown video, you'll recall that the planet had deep, deep grooves cut all the way around the circumference of that band bearing surface, and that's because this was too tight. Now, as far as I know, no work has been done on this unit other than you know, the spacer plate being drilled out, but it's possible somebody went in here maybe to fix a reverse issue and they swapped the pin out for another pin, because those pins are selective. So for example, at the tip of the pin, you would see indicator grooves or lines to tell you specifically which pin you have. And if you have the Kent Moore piston travel / band adjustment tool, you would use that tool, and that tool would tell you which servo pin you needed to install based on, you know, the procedure that Kent Moore has you do. Since almost nobody has that thing, I'm not going to show it here, but suffice to say, what we need to do is we need to grind on the pin until I'm at about 150 thousandths or so. Once I'm there, then we'll go ahead and we'll install the test gasket, the cover, and then we'll assess for drag. Alright, so I've ground on the piston a little bit, or on the pin rather, and what I did is I went 1/1000, took it off, 2/1000, took it off, and 3/1000. So I'm going to see, because it's not going to be there yet, but I like to sneak up on it. I don't want to overshoot it. So I want to see how much, if anything, that I gain by doing that. And then that'll help me gauge how long this thing needs to be, you know, held to the grindstone so that I can get where I need to be. Alright, so once again, we'll compress it. Looks like 94 thousandths, 93 thousandths, 94 thousandths. So 1/1000, 2/1000, 3/1000, assuming this measurement holds consistent, is equivalent to 15 thousandths of an inch travel. Alright, let's see. This feels like it's in there. So measuring the same spot, that's the other thing. You want to make sure you're measuring in pretty much the exact same spot. And like I said, you got to kind of do it quick. 100 thousandths. So I'm going to try again. So we got two different measurements, 90 thou, 100 thou. Hundred thousandths. So those last two measurements felt good. So what I'm going to do is I'm going to go back to the grinder. If 1/1000ths equals roughly, let's just call it 7 thousandths of an inch travel, and I did 1/1000, 2/1000, 3/1000, so that, you know, picked up roughly 20 to 21 thousandths of an inch. I basically need to hold it for another 7 1/1000ths count, and then that should give me between 150 and 175. Alright, so I took off a little bit more. I went 8 1/1000ths, so 1 1/1000th, take it off the grinder, 2 1/1000ths, and so on. So we'll give it another shot and see where we are at. Alright, once again, gotta put all my weight onto this thing, get my plunger ready to go. Alright, so we're at 140 thousandths. And that's like 146, 147. You're going to get variability when you do this because the spring just wants to push back on you. And that was, it had already moved, so. $140. All right, I'm gonna give it 2 to 3 more rounds of 1 1/1000ths, and that should get us between 150, 175. All right, let's see if we have success or if we have to continue to grind. So I did 3 1 1/1000ths on the grinder. Now, see, each time I'm relaxing my body weight even subtly, it wants to spring back. So just shy of 150. It's going to need a couple more go rounds. Okay, you know what? I actually felt like I got an accurate reading. So I'm at 168. If I can duplicate this again, then we're gonna stop. And this is where that homemade tool that CK Performance shows you in his instructions, and it's available online too. 150. I feel like I wasn't fully bottomed out on that. Okay, I felt like I was there. So 170, I think we're in good position to install the test gasket and cover and torque all the bolts to spec and see where we are at. So all these bolts get 18 foot-pounds, okay, and your flange here is going to go there. So I have this gasket kind of wallowed out for both TH400s and 480Es. So if you're wondering why the holes looked a little oblong, that is the reason. So get each of these bolts started with a few threads. You don't want to cross thread anything, obviously. So 18 foot-pounds, no particular torque sequence, I just go crossways with it. 3 and 9, 2 and I guess 7, and 10 and 5. Alright, now we're going to assess drag. So I'm hoping there's no drag. Alright, so you can see the output shaft a little bit better. And that feels nice. There's no drag whatsoever. Alright, so now I'm going to see if I can do an air test here. So you're going to stick your nozzle right here in this port. Just, you know, insert it all the way in. And then when you put air, you're going to see the rear planet move a little bit, and that's because the band's grabbing the front planet, causing the rear planet and output shaft assembly to move with it. Okay. I could hear it firmly grabbing that band surface. And that's what you want. So you're hearing a lot of hissing for two reasons. One, that nozzle isn't making a perfect seal, and two, this gasket's been used like a billion times, so it's not sealing. Alright, now what we're going to do is we're going to take this cover off. We're going to bring the accumulator piston and spring over. We'll put the O-rings on there, and then we will assemble all this for the final time. We'll be done with the low reverse assembly. So this method is a little tedious, and maybe I made it look even more tedious than it really is. But once you've done it a few times, obviously you'll get a good handle on it. But the main thing is you don't want your band clearance to be too tight on these. You know, like I said, if you watch that teardown inspection video, you'll see firsthand the effects of a band that's too tight, where the travel is too much. Somebody must have put a different pin. So at some point in the past, there must have been issues that the owner had with reverse. I mean, if this had never been touched, I can't see how you would have this much wear, you know, that much drag on the band surface there. Okay. I just want to wipe off some of the residual there. And then we'll put all fresh assembly lube in the board. Okay, so here's our new gasket. And then put our accumulator spring there. And then here is our 1-2 accumulator. So for TH400s, you want to make sure you replace the Teflon sealing rings on the equivalent 1-2 accumulator piston. Alright, they'll get worn and you'll have slipping from first to second gear if they're not sealing adequately. So on the 4L80Es, you have the rubber D-rings, so it's not as much of a concern. But if you replace the scarf cut, or excuse me, the one-piece Teflon sealing rings on the TH400, you won't have any issues. And I say that because some people may be tempted to reuse those pre-existing sealing rings, and you don't want to do that. Alright, so I lubed up the D-rings there, and then I'm going to lube up the inner bore of the piston for low reverse. Let's get it nice and saturated. I'll lube up in here too, and then just go over this one more time. Let's get it nice and square and press it in. No big deal. Okay, 97 and up, this whole assembly changed. They went to kind of a domed cover and a domed piston, and the pins are all different lengths. Like, they're dramatically different than the pins for these early units. And so you can't intermingle them. You know, you have to use early with early. And you can easily tell by the fact that, you know, the earlies are all flat, just like TH400s, and then 97 and up, they'll have a domed piston and a domed cover. Alright, so the pins themselves are not interchangeable either. Like I said, they're dramatically different in terms of their length. The little spring assemblies are different. They had you know, there was like a larger buffer spring that went into the back underneath of the 1-2 accumulator piston. So if I do a teardown inspection on a later 4L80E, which I will eventually at some point, I'll go ahead and talk about that difference. Alright, so now we have the new gasket. You want to make sure that the gasket sealing surface here is facing the case. So it'll go just like this. And same thing, just install all your bolts so that you've kind of pre-lined up your bolt holes in the gasket and the cover and those on the case. And same deal, just get each bolt started with a handful of threads. Make sure that all of them are in fact threaded in. You don't want any mishaps. "18 foot-pounds on the torque." If you neglect to torque this, you will have, I should say it's probable you will have slippage in reverse. Okay, these bolts have to be torqued before that metal gasket will actually seal. Oops. So just crisscross pattern like usual, as if this was like a 6-lug wheel, I guess, and you're torquing your lug nuts. Alright, do one last air check. So we got to squeeze that nozzle in there. Yeah, it's iffy. The whole boatload of air blowing out the back of it, but I mean, I think you can see and hear it. I mean, that feels solid, even with all the air hissing, because the outside diameter of the nozzle is much smaller than the inside diameter of the air check port. Alright, last but not least, go ahead and torque your intermediate feed bolt in the center support. It takes 29 foot-pounds per the ATSG manual. I think I mentioned 30 to 34. If you were to torque it to 34 pounds, it'd be fine. You're not going to break it, but it does call for 29 in the manual. Okay, so we're ready to move on.